Welcome back. This is not part 5, but I made a new discovery and I couldn't sleep last night, so I thought I'd share it with you today and get it off my chest. Okay, so I was about to give up my theory because there's a couple of reasons I decided to post this discovery on YouTube, because I wanted to elicit professional opinion, that is, geologist, scientist, to look at my findings, and if they disagree, bring up their arguments, and if I'm right, I will be proven right. If I'm wrong, they'll prove me wrong. They will bring up arguments and problems with my theory, and my theory will be shot through full of holes, and I can give up on this idea and move on with my life. And I was just about to do that. In fact, I got a very interesting response from a physics major called Dashes, and he argues with the fact that it was a nuclear eruption. And I want to put that aside for now, because that's a very big and very complicated point, and I'm not going to bring that up now. But he did make the point that the radioactive material that a nuclear eruption would have would rain down all over the earth, and you would find lots of evidence of it. And that is absolutely a valid argument, and I cannot argue with that. He's right. Just like any volcanic eruption, it rains ash, sulfur ash, all over the earth, and they can find layers of it in the geological record. Another argument was brought up by Daft Tool that the event which caused the extinction of the dinosaurs, and he's a biologist, the event that happened 65 million years ago was not associated with a volcano because there is no iridium-rich layer of sulfur. Now, if it was a giant volcano, as I suggest, you would find massive amounts of volcanic ash all over the earth. In fact, the size I'm predicting of these eruptions, you should find a 10-foot pile of ash all over the earth. So thank you, guys. I mean, you're really shooting holes in my theory, and I swear I was checkmated, and I was about to give up, say, yeah, I got two massive amounts of evidence that are gone, that I have no evidence for. And I started to have to accept the fact that I was wrong. And then I kind of like to, this is the second reason that I decided to post this on YouTube. I believe that most scientific discoveries, you find out about them after the fact, when all the scientists agree and their papers are published, and the news and media get a hold of it. I wanted you to see how an idea develops, how a theory and how a discovery develops. It doesn't develop like you get the idea all at once. You make a lot of mistakes and you have to recalculate and go in a new direction, and that's exactly what I've done. Faced with these obstacles, I thought, oh no, I have to rethink that. Where did this evidence go? I have to account for it. And Dashes thinks how convenient it is that, because I explained a bit of my argument to him, what I believe is the force of this explosion would be so great that it would throw almost all of its material out into the atmosphere. In fact, through the atmosphere, it would blow a hole through the atmosphere, and it would go out into a near-Earth orbit. What little is left of the Earth's atmosphere, and this material would just float around in space, being bombarded by solar energy and being blasted. Yes, there would be radioactive isotopes that would rain down, but they would rain down gradually as they fell back to Earth. They would be mixed in with the atmosphere. In fact, there would be almost a secondary atmosphere produced as the gas and clouds were blown into the atmosphere. So a lot of my evidence would be gone, and he said, how convenient, your evidence is gone, and you can say that it disappeared because of the force of it. And I don't like that. I would much rather find the evidence, the actual layer of soot, but unfortunately if it was blown out past, if the radioactive isotopes were blown out, and if they came in gradually over time and filtered down through massive layers of atmosphere. So I mean, they might be there, but minute traces and undetectable, against regular radioactive noise. I mean, we get all kinds of radioactive bombardments of one type or another from outer space. So I can account for the missing evidence, but that doesn't help me prove my theory if my evidence is gone. And then I started to rethink, well, maybe Daft Tool is correct about, and I better speed this up to get under 10 minutes. Daft Tool may be correct about the meteorite strike, so I had to maybe accept that it was a meteorite strike. And so I looked at the evidence again, and the magnetic markers, the type of iridium, the layer that it was laid down in, I actually had to conclude that this is correct. A meteorite did hit the Yucatan Peninsula, and it did hit 65 million years ago, and it did cover the dinosaurs. But the dinosaurs were already dead. Part of the reason that I jumped to this new hypothesis is because of the proximity of where I predict ground zero of my mega eruption to be, and where I believe now to be conclusive fact that I believe it is conclusive that a meteorite did hit there. So if a meteorite did hit there, what happened? So if that is true and mine is true, what's going on? So as you can see, I've drawn a little map here, and here's the proximity issue. Stand back so my shadow's not on there. Here's where I predict ground zero. Here's where the meteorite hit. What happened simply was that this explosion happened first. It blew massive amounts of debris into the air. Some of these chunks would be huge, like a couple miles across. Even if the chunk was 10 kilometers, and that would be about 6 miles, if it was the exact same size as the one that hit the Yucatan Peninsula, if this would only account for 1.3% of the Earth's crust that would have been blown out into orbit. And just like Space Lab that came crashing down to orbit, down to Earth because its orbit was in a decaying orbit and not, yes, Earth's gravity pulled Space Lab in because they didn't have the correct orbit. So eventually this material, and I'm rushing, that's why I'm missing points. I made one video already, it was too long, so. The crust was blown like a rocket ship straight out into the atmosphere, through the atmosphere, into near orbit, and it floated around in space, just like a satellite, in the exact same latitude. That's why it occurred to me, because this is in the exact same latitude. It went straight up into the atmosphere, and just like the rings around Saturn, if you have material, debris, that is caught in an orbit by a planet, it will form a ring, a very thin plane. So this is exactly what would happen to the debris field. It would come up and it would be in this perfect orbit. And it would just be this big debris field, and it would collect. And eventually, one of these pieces, and many of these pieces would rain down. In fact, that's probably what repaired the atmosphere. As they crashed into the ocean, it would throw up many gases. These gases would form to produce clouds and atmosphere. Also, so yes, it came crashing down, and it would have happened after the fact. It could have happened as much as 10 years after the fact, 100, 1,000 years after the fact. But in a geological timescale, this is only a fraction of a second. It's a mere second. And it's too close for geologists to distinguish. The dinosaurs may have already been dead, and then 100 years later, 1,000 years later, a meteorite comes crashing down and buries them in a rich uranium deposit. Okay, today's kind of interesting because a very similar event to the mega volcano that I described happened in New Zealand. This is March 18th, and a crater lake, it burst its banks and come rushing down the mountain in a giant mudslide. You should look at these pictures, because if it didn't go down there and cracked and went down into a magma chamber, we would be talking about exactly the dynamic that I am describing. So I hope I'm done. I'll watch it again, probably missed something. I hope it's under 10 minutes, and this was just an update. I really didn't want to do this. I just thought I'd have a better sleep if I got it off my chest. So I hope I concluded everything, and I hope it's under 10 minutes. So there are lots of problems, but problems are meant to be solved.